Hello! Video lesson topic: degree measure of an angle. Like measuring segments, we choose units of measurement for angles. The subsequent measurement is selected to measure the angle. Let's take into account a complete angle and divide it into 180 equal parts. And one such part, that is 1/180th part of the turned angle. 1/180 part of the turned angle is called a degree and is denoted as follows. 1 degree is 1/180 part of the turned angle, in such a way that to measure the degree measure of an angle, you need to calculate how many times the angle fits into this angle. Suppose this angle fits 30 times, then the degree measure of angle AOB will be 30 degrees, written as follows. Angle AOB is equal to 30 degrees. But in some cases, it happens that the angle in 1 degree fits into a certain angle and not a whole number of times. For example here,
angle EBD. But if we suppose that it is necessary to consider the potential implications of this scenario in order to make an informed decision,
an angle of 1 degree does not fit a whole number of times, then other units of measurement are introduced. Namely, an angle of 1 degree is divided into 60 parts, and 1/60th of a degree is called a minute, and is denoted as follows by a dash. 1.6 degrees is referred to as a minute. Subsequently, we are able to compute the complete number of degrees and a certain number of minutes. If this is insufficient, then an extra 1.6 portion of a minute is introduced. It is referred to as a second and is denoted as such. And let's say it was determined here that the angle EBD is equal to 29 degrees, 23 minutes, and let's suppose that it is 11 seconds. We know how to compare angles with you. Let's assume we have two angles. Let's represent them as angle 1 and angle 2. To compare these two angles,
we need to superimpose one angle onto the other angle.
If these angles coincide, then they are equal. So, the degree measures of equal angles are the same. Accordingly, if angle 1 is equal to angle 2, then their degree measures are the same.
Similarly, if angle 1 is greater,
the greater the angle 2, the greater its degree measure.
And vice versa. If it is smaller, then
the measure of its degree will be smaller.
Let's now go back and return to the obtuse angle that we were discussing earlier.
Let us consider an angle AOV. Since we previously mentioned that 1 degree is equivalent to 1/180 of a full angle, it follows that the complete angle will be 180 degrees in total. Thus, the angle AOB, its degree measurement is equal to 180 degrees in terms of its magnitude and size. If I divide the straight angle into two equal angles, let's say I draw a ray OC that divides it into two equal angles, then each of the resulting angles, AOC and COB, will be equal to half of 180 degrees. That is 90 degrees. I will write, for instance, the angle COB is equal to 90 degrees. That is to say, half of the unfolded angle is 90.
An angle of 90 degrees is called a right angle.
If the angle is 90 degrees, it's considered right. On the drawing, it's often shown like this. If right angle, emphasized.
With such a tiny right angle, of such small dimensions,
let's take into account an angle. Let's designate it as A and B for further reference. And if we divide this angle by a ray emanating from point O into two angles, it is obvious that the degree measure of angle A to angle B will be equal to the sum of the degree measures of the angles.
An article providing information about C, as well as discussing the angle SOB in detail and its significance.
If we divide an angle into two angles, then the sum of the larger angle will be equal to the sum of the two smaller angles. Dividing it into three parts gives us the sum of three angles. Let's solve an example. Let us consider an angle AOB. Let it be divided by the ray OC into two separate angles. We can denote these angles as angle COA and angle COB respectively. It is known that the two resulting angles, one of them is 50 degrees larger than the other resulting angle. In our case, angle is larger.
Therefore, this one will be smaller.
Let's represent this angle as x. If this is increased by 50, then it will be x plus 50. And now, how can we find the angles AOC and COB? We are aware that the total of these two angles provides us with angle AOB. That is, the total obtained by adding x50 and x is equal to the degree measurement of angle AOB in this scenario. But the angle AOB is turned, so it is 180. The equation remains to be solved. X 180, 50, X 65. Smaller 65 degrees, larger 115 degrees.
X is 65, so the smaller angle is 65 degrees and the larger angle is 115 degrees.
And finally, I will tell you about some types of angles. We already know what a reflex angle is. That is, a reflex angle is an angle of 180 degrees. We know that if we divide this reflex angle in half, we will get a right angle. That is an angle of 90 degrees. Here we have 180, which is reflex.
An angle of 90 degrees is referred to as right angle if
suddenly we have an angle that is smaller than 90 degrees. Let's say I will draw another ray here. I will have an angle smaller than 90 degrees.
Let's consider such a scenario. This particular angle is commonly known as an acute angle due to its small measure.
An acute angle is a degree measure less than 90 if the angle is greater than 90 but less than 180, for example, like this.
The angle that is formed by drawing a ray in this particular location is known as an obtuse angle. This is an angle of foolishness.
This video lesson is over.